Olbers Paradox, why the night sky is dark in an infinite universe. Look up at the night sky. Beautiful, right? Billions of stars stretching across the universe. Except, wait a minute, why is it dark? If the universe is filled with trillions of stars in every direction, shouldn't the sky be as bright as the surface of the sun? This is Olbers' paradox, the cosmic mystery that once implied the universe should glow like a light bulb, but instead looks like a broken one. Let's pretend the universe is infinite, no edge, no end. Every line of sight should eventually hit a star. Every direction, up, down, sideways, packed with light. Add them all up, and the entire sky should be blindingly bright, not black. So why is space so dark? That's the heart of Olbers' paradox, named after German astronomer Heinrich Wilhelm Olbers, who posed it in 1823. But the question goes back even further, to Kepler and Halley, astronomers who couldn't shake the same weird thought. If the universe is infinite and eternal, then night should never fall. Here's where it gets awkward. If you spread stars evenly through infinite space, the number of stars you see increases faster than their brightness fades with distance. Mathematically, that means the sky's brightness should be infinite too, basically a giant cosmic torch. But when we look up, it's mostly black, not even dim grey. So either the universe isn't infinite, or something is blocking the light. Olbers thought he had the answer: interstellar dust. Maybe space isn't black. Maybe it's just foggy. The problem? Dust doesn't delete light. It absorbs it, heats up, and then re-emits it. Given enough time, the dust itself would glow until the whole sky still ended up bright. Nice try, Heinrich. Back to the chalkboard. The true answer didn't arrive until the 20th century, with two revolutionary discoveries. The universe has a beginning. It's still expanding. If the universe isn't eternal, then light from the most distant stars simply hasn't had time to reach us yet. The speed of light acts like a cosmic speed limit. We can only see as far as light has traveled since the Big Bang, about 13.8 billion years. And because space itself is expanding, that light is stretched into longer, redder wavelengths, many beyond visible light. The universe is still glowing. We just can't see most of it. So if the night sky is dark, where did all that light go? It didn't disappear. It shifted. As the universe expanded, visible light from early stars and galaxies stretched into microwave radiation, the faint afterglow of the Big Bang. Astronomers can still detect it as the cosmic microwave background, a uniform hum of radiation filling every corner of space. So technically, the night sky is bright, just not to human eyes. Olbers' paradox was more than a curiosity. It was a clue. A simple question that pointed toward the truth that the universe had a beginning. Before this, many scientists believed in a static, eternal universe, but a dark sky proved otherwise. No infinite, unchanging cosmos could ever stay this dim. Something had to have a start, and an edge. In a way, Olbers accidentally helped lay the groundwork for the Big Bang theory. A lot of people still get this wrong. It's not because space is empty, it's packed with stars. It's not because dust blocks light, dust glows too. And it's not because stars aren't bright enough. They're plenty bright. The real reason is simple but profound. We live in a finite age, expanding universe, where light can only travel so far before it fades into invisible microwave radiation. Space isn't dark because there's no light. It's dark because the light has moved on. Olbers' paradox isn't just a physics lesson, it's existential. That darkness you see every night is a cosmic receipt for the age of the universe. It means we exist at a time when the stars are still burning and the light hasn't had time to fill the void. If the sky were blindingly bright, there'd be no darkness, no contrast, and no Earth cool enough for life. So the night sky's emptiness isn't a failure of physics, it's the reason we're here to notice it. Olbers was just one of many who looked up and asked too many questions. His paradox connects to others. The Fermi paradox. Where are all the aliens? And the black hole information paradox. Where does information go? All three show how simple questions can shake our understanding of the universe. Sometimes the deepest discoveries start with just looking up and saying, "Huh, that's odd." Olbers' paradox teaches us two things. Our intuition is terrible at infinity. Darkness can mean light in disguise. Every patch of black sky is filled with light that's traveled billions of years, stretched beyond our vision. Every glimmer we see is a tiny survivor of a brighter past. The universe isn't empty. It's just bigger, older, and stranger than we can see. So next time you stare into the night sky and see nothing but black, remember, that darkness is proof that the universe has a story, and you're watching it mid-chapter. This is 5-Minute Paradox, where we turn the universe's weirdest questions into 5 minutes of curiosity. Like, subscribe, and don't forget to look up tonight. The answers are glowing right past you.